Two conducting plates of a capacitor have equal number of free electrons in normal state. Connect the capacitor to a DC voltage source by closing the switch. The electrons are removed by the positive pole of the cell from plate A, and hence plate A becomes positive. An equal number of electrons are deposited on plate B, which becomes negative with respect to plate A. Due to the accumulation of electrons and positive charges, a voltage develops across the capacitor which opposes the battery voltage. The electrons move, and thus a decaying current flows from the negative cell terminal to the right side plate of the capacitor. A decaying current flows from the positive cell terminal to the left side plate of the capacitor. These currents can't pass through the capacitor due to the presence of insulation between the capacitor plates. The circuit consists of two series but opposing voltages. As the voltage across the capacitor increases, the effective circuit voltage, which is the difference between the battery voltage and the capacitor voltage, decreases. This in turn causes the above said decaying currents. Once the voltage across the capacitor equals the battery voltage, the resultant voltage in the circuit becomes zero. So the current also becomes zero. The capacitor is now fully charged. If the switch is now opened, the charges accumulated in the capacitor plates remain there itself, and there will be a voltage available at its terminals. This is why the terminals of a capacitor shall not be touched without following suitable precautions. If you want the charges to be removed, the terminals have to be short-circuited across a resistor. In any case, the terminals shall not be shorted by a solid wire, since the discharge current will be very high and the capacitor may fail sometimes due to heat developed. If the capacitor is left idle with charged condition for a long time, the charges may get slowly neutralized by crossing the dielectric. This happens very, very slowly, for hours or days depending upon the resistance value of the dielectric.